our final speaker before lunchtime on future tools and materials is Carole Colette. She is Director of Design and the Living Systems Lab and Professor in Design for Sustainable Futures from the Central St. Martin's University of Arts in London. Her talk is about the emergent practices in biofabrication. And in Carole's own words, she grows things instead of making things. Please welcome on stage Carole Colette.
Good afternoon. Can you hear me? Okay, yeah. So first of all, a really big thank you for inviting me to share my work and my practice today here with you. It's a real privilege to be able to expose what we do. Let's see if that works. Great. So what I want to talk to you about is in twofold. So I'll talk to you a little bit about the context of my practice, because for me, the why, what I do, is as important as the how. And then the second part of the talk will be a bit more about my work. So I'm a maker of things, I'm a maker of matter, I'm a maker of thoughts, but fundamentally my practice is about sustainability. That is what drives what I do. And I want to share with you why I think it's really crucial, why I think it's really important, and why I think we should transition to new ways of making, to new tools and to new materials. So one of the key drivers for my work is to look into biomimicry, biofabrication, and to think about how I can operate within the context of the Anthropocene. So biomimicry is how we can actually mimic the way nature makes things, the way nature behaves, looking into adopting biological principles into what we do. Biofabrication, and I'll show you examples of that, is means to use biological dynamic complex system to actually fabricate material. And the Anthropocene era is an epoch which was actually qualified by a Nobel scientist called Paul Crutzen. The idea here, and that's what he's arguing, is that we are, as a species, the first species in the history of the planet to impact on the geological forces of the planet. So you will have heard of climate change, of course, but ocean acidification, looking at how our use of phosphate is actually damaging our oceans. We are actually changing the way the planet performs. And I want to look at how we can actually not be part of that, but actually be part of a much more positive story with our planet. So I'll show you two examples of how biological material can actually be an inspiration for us as craft makers and designers. These are diatoms. Diatoms are microalgae, and what you're looking at here is magnified photographs of their skeletons. So you can see there's lots of different kinds of diatoms, different shapes. But look at the sort of precision engineering that you're looking at. It's incredibly exquisite. I mean, it could look like jewelry. Here's another example. Again, this is a diatom that lives in cold water in the ocean. And what diatoms do, and they have the biological ability to do this, is they harvest traces of silica they find in water, in seawater, and they turn that silica into a glass-like skeleton. Which is designed, so it's their skeleton, but they simply do that at ambient temperature without using any chemistry, without using any heat. Here are other examples of diatoms, but this is how we make glass. We use intensive high levels of energy, usually fossil fuel-based energy, to make glass. So if you look at a natural model, like a diatom, they can make a glass-like skeleton at ambient temperature, simply because they have the ability to turn silica into their skeletons. We, as a species, we don't know how to do that yet. We don't actually know how we could replace them. And we now have, there's a map of endangered elements, not endangered species, but some of those rare metals, we don't know where else we can find them. So we're currently making and producing billions of mobile phones using limited resources in the form of rare metals that we don't know how else we can replace them. If you look at a natural system, think of a tree. You will have known a tree, or particularly at springtime when the leaves come out. So this is biofabrication. A tree will actually make cells that will turn into leaves, into bark, into branches at ambient temperature, working locally and using mostly these 6 elements. So again, another example of how actually nature makes compared to how we make, and how our way of making has a devastating impact onto our planet. Another key driver for my work is something which is quite recent, which I would say in the past 15 years has really come up to the surface. It's the uprising of synthetic biology and what is now called the organism industry. So as a designer now, actually one of my manufacturers is actually called the organism industry, and I'll explain what this is. Synthetic biology is effectively a means to actually design and write up a genome on a computer. You can then print the DNA, boot it up in a cell, and create a new kind of species. There are a lot of research now around the world in synthetic biology, and you will find yeast, algae, bacteria, and microbe completely reprogrammed to produce a bespoke substance. For instance, artemisinin. So in the medical field, it's looking at getting living systems like yeast to actually produce medicine. We're now producing silk, vanilla, palm oil. There's research into nylon, into many other ways of making. And the idea here is to use local fabrication at ambient temperature using a biological system. That's called synthetic biology. And that is changing the technological landscape in which we operate as makers. I'll show you a few brief examples. This is Modern Meadow. This is actually looking at tissue engineering and synthetic biology and looking at actually growing leather in a lab. And they launched just a couple of weeks ago. This is called Zoa. So it's the idea of actually fabricating an animal-free leather that we can grow in a lab. Knowing that fabricating leather is very toxic, both in terms of the actual chemicals used for the leather, but also simply the number of cows we have actually emits a lot of methane, which is really problematic in terms of climate change. So looking at shifting our current model of making leather to growing leather in a lab. Boarthread, another US-based company that back in 2015 didn't communicate anything. Their website said, we are very busy doing some interesting things, but our lawyers tell us we can't tell you anything. To 2016, launching the first commercial silk made by yeast. And what I want to show you here is what I think is very interesting in terms of the idea of craft. So basically they've reprogrammed the yeast to make a silk protein in a liquid form. And it is growing in this. So it's like the idea of brewing beer. So you could reuse your Guinness factory to actually start thinking, what else could we brew? And the idea here is that, so yeast will self-replicate, they will grow happily, and then when they've produced the silk protein, you kill the yeast and you harvest the silk protein, which you then kind of re-enter a sort of textile chain, and then you can see that's the sort of filament made with the silk produced by yeast. Yeast will live on sugar, so you need to feed it with sugar. So there's potentially an interesting aspect here in terms of sustainability. How much sugar would we need if we really move to that fabrication model? But this is trying to move away from working with our current manufacturing model. And this I wanted to show because actually this is, historically speaking, quite significant. You've got Stella McCartney, world-leading fashion designer, standing next to the head of Boarthread, a sort of a scientist, and now partnering together, so fashion partnering with synthetic biology to create silk, and this is the dress that Stella made with that silk. So very, very new landscape, and I think Annie touched a little bit on this earlier on in the introduction. The idea of actually collaborating with science is not just a hybrid emergent practice. It's now happening at that level of industrial production. Adidas did the same with a German-based company working with synthetic biology and AmSilk. And I want to show you briefly an extraordinary designer, both an architect and a textile designer, a material designer, who's working with biology to rethink how we use how we dye fabrics. The textile industry is a very damaging industry, particularly with its use of water and chemical dyes. And she's developed a protocol in collaboration with UCL in London, and she's just back from a residency at Ginkgo Bioworks in Boston. What she does is she creates different kinds of environments for bacteria which will naturally produce a color. But by changing their food and their environment, she controls a whole range, a whole palette of colors to actually dye fabric with bacteria. And that considerably reduces the amount of water. It's not using any chemicals, any fossil fuel-based petrochemicals. So again, moving away from petrochemicals to biological means to dye and print fabrics. The third driver I want to talk to you briefly about is, and you may have heard a lot about the circular economy. I talk about the circular bioeconomy because I think for me that's even more specific and even more interesting. The idea here is again that we're moving away from a linear industry, linear context where we take some material from the planet, we transform it, use it, and we dump it. The idea of circular is that whatever we take, whatever we create as waste is actually becoming a new raw material or a new resource. But what I'm interested in is in the circular bioeconomy. And the bioeconomy is a growing concept. There's about 40 countries now in the world have defined a strategy for their bioeconomy. And it combines very traditional agricultural, permaculture, but also together with the latest biological research in synthetic biology. And again, it's the idea of an economy not based on fossil fuel, but an economy based on biological material. And you will find, so here's alginate, so how we can make a fiber with algae, so the idea of going from, with seaweed, so going from seaweed to fiber. There's quite a few people working on this now. This is the Vivo Barefoot, which is actually made from algal blooms, and algal blooms are very damaging to the environment. We have suddenly, you may have seen suddenly all these mass amounts of green algae, and they actually absorb all the oxygen and all the fish will die. So this company has looked into, well, how can we take this is an opportunity, it's an environmental challenge, but it's also an opportunity. This incredible growth of algae could become a raw material, and they've made a shoe with it. Again, the idea of circular thinking, making yarn with coffee. In London itself, there's about 200,000 tons of waste coffee a year. I don't know how much you love your coffee in Dublin, but it looks like in London we drink a lot of coffee and we have all this coffee waste. It can be used and can be turned into yarn. Same with orange peels. So this is a company actually creating fibers with the leftover of the orange peels from the juice industry. So that's another example of what I call a circular bioeconomy, looking into what is a bio waste turning into and upcycling into a new product. Oh, I'm getting a strange message on here, but you're not seeing it, that's good. And even poo is really useful. So this is manure couture and actually extracting cellulose from cow manure to make fiber. This is Anushka Kaul, who is a graduate from the Masters in Material Futures at Centre St. Martin's. And I think what's interesting about her idea of the sort of upcycling bioeconomy is she's also joined the notion of social innovation with it and really working with a deprived fishing community in south of England, looking into how you can actually create new opportunity, create new jobs, by helping fishermen to actually turn fish skin into products again. So the idea is that even though the market in selling fish has reduced, they have less fish, they can find less fish, can they actually use the skin to actually revive the community? This is just a little kind of to show another way to think about 3D and 4D printing. You may be familiar with this is Killer Tibbets from MIT, the self-assembly lab. And again, this is very much inspired by biomimicry and by biology. So if you think of a pine cone, hopefully you will all have seen how a pine cone will be closed, but as soon as the environment changes and it becomes quite hot and humid, it sort of opens up. And that happens because the fibers in a pine cone are aligned in different ways, and which, when humidity increases, it will make the fiber geometry sort of react and sort of open up. For the pine cone, it's a means to sort of eject its sort of seeds and sort of to replicate. But this work is very much inspired by this idea. So it's actually 3D printed wood grain. And you can see, particularly on the bottom, how if you print in different directions and using different geometries, when it's exposed to humidity, it's forms into a product. So here's the idea of going from 2D to 3D by simply relying on biological principles to make that happen. This is, and I'll come back to the notion of mycelium, but this is Dutch artist, Dutch designer, working on 3D printing food and a frame to grow mycelium. So the idea is to grow a chair. And the idea, the mycelium is the roots of fungi. So basically the mushroom is the fruits of mycelium. And this is how you could actually control mycelium to grow materials. Another way to think about the idea of printing, and this is really sort of divergent practice in a way, but this is really looking at how you can use silkworms to actually print matter. This was produced by Media Lab Binary Uxman back in 2013. The idea is to create the first infrastructure by stretching cotton thread and then depositing silkworm on the structure. And what you can see here, it's a silkworm busy printing its silk. So the thicker yarns, the thicker white yarns, are the ones that were actually the given structure. But the very fine mesh has been deposited by the silkworm. So it's the idea of if you guide a silkworm, if you create a basis matrix in some ways, you can actually get the silkworm to continue to create the material to actually produce your, in this case, structure. This is Zuzana Kombozova, another graduate from our Material Futures Masters, who's looking at actually how you can print food in particular places to actually create bacterial cellulose, which will be thicker in parts and thinner in others. So it's the idea of using that control to grow material in different thicknesses. This is not so much about biology, but the idea of circular stream. And so this is Jenny Bank, another one of our graduates, who's really looking into how you could print waste polyester. Polyester being an oil-based material. About 70% of the fibers in the global textile industry are polyester. How we can turn polyester waste into new material is what she was interested in. She developed a technique to grind polyester fibers mixed with a bio binder, which she developed, to actually print polyester fibers onto polyester as a means to create patterning techniques. So again, the idea here is that polyester waste becomes a raw material for 3D printing. So this is the context in which I operate, looking into our sustainable impact on the planet and the context of the Anthropocene, looking at biofabrication, the organism industry, looking into circular bioeconomy. And what I want to show you today is a few examples of some of my practice which actually engage with these. So I run a lab called the Design and Living Systems Lab at Centre St. Martin's, and really the idea is to explore the interfaces of biological sciences with design and craft. What I'm really interested is in navigating between the handmade, the man-made, and what I call the grow-made, and I'll explain what the grow-made is. So I work my work is in three strands. So either I look at biomimicry and look into imitating a natural model, or I consider a natural organism as a co-worker. So I'll show you examples of working with mycelium. So my co-worker is not sitting next to me, it's actually an organism I have to grow and feed and nurture to be able to get what I want from it. Or working with synthetic biology and hacking nature to create new materials and new systems. So one example is BioLace, and this is the one that you will see in the brochure. And this is something I started looking into back in 2007 even, but started working on it in 2010, when synthetic biology was really not very well known. In fact, the first synthetic biology species was really produced in 2010 by a scientist called Craig Venter. But what I was interested in is looking into the idea of this quite abstract technology and how I could use it to maybe look at producing future textiles that would be much more sustainable. My first question was, how does nature make a textile? And if I can find out how that happens, could I then speculate that we could create this sort of genomes that uses natural ways of fabricating textiles? And so nature does make textiles. This is a lace bark produced by the Lagetal lageto tree, which is in Jamaica. coconut bark, and you can see how they actually look like a piece of woven cloth. Mushroom that makes a little lace skirt. So that means in nature, you can find examples of species, organisms that have a DNA and a genome that actually codes that intelligence into the materiality. So I wanted to speculate on how can you move from a natural way of making lace, which is the mushroom way, to our current existing production system, to a future model, which in my scenario was in the year 2050, looking into urban farming, growing food and textiles at the same time. So in my work, I use photography as much as I use actually making hands-on. So this is this is a real strawberry, but this is not, the strawberry hasn't grown the lace. This is really using photorealism to create what we could do. And in speaking to biologists who tell me, well, it would take us 20 years to get there, because currently we can reprogram small organisms, much simpler ones, like yeast and microbe. But to reprogram entirely a plant system is far more complex. But the idea here is that you can harvest food and textiles at the same time. I was also commissioned then to actually make a lace doily with roots. So this example here is actually made with strawberry roots. And it's a kind of strawberry that makes black roots. That's partly why I wanted to use that strawberry. And this is actually used a very traditional lace pin techniques for those of you who know how to make lace. The challenge here is that if you work with fresh roots, they break, so you can't actually pull to create tension. So you have to find tricks around it. But the idea here was to develop or adapt a lace technique to create this lace doily and to try and sort of create this scenario for the future. And then I moved into a basil numero 5, and the idea here is to look into a scented lace produced by plant. Equally, I'm looking into biofur, the idea of growing fur in a lab, and I'm again using speculative design to look into, as a way to navigate between the idea and the actual matter and the way of making. So looking into creating, again, speculations where, and this is based on a quote from Juan Henriquez, who's a biologist based in the States, who talked about the fact that with synthetic biology, we can cross boundaries between species, between animal and vegetal. So I wanted to sort of, in a way, poke the idea with the idea of, could we grow fur with mushrooms or with plants, and can we look at animal-free fur? But I'm also talking to biologists actually working to actually transforming yeast and microbe to create keratin in a lab. Briefly, I'll end with this project, which is mycelium textiles. So I'm looking at growing mycelium. Again, mycelium is this network of roots system that you find in a fungi, and I'm looking at, can we use mycelium to develop different coatings for fabrics, which currently are polymer-based and oil-based. So here's mycelium as it grows. Mycelium loves growing on anything cellulosic. So this is mycelium grown on a lace. There was a hole in a lace, and actually I tried to see whether the mycelium would mend it. So it was a sort of new darning technique in a way, but looking at mycelium coating. And what's interesting there as a designer, as a maker, normally you take wood, you take fabric, and you transform it. But when you grow things, you have to control the environment of growth, and that control is also what helps you shape. And so I'm looking at mending, coating, patterning, and I'll show you various quick examples, so creating tartans. This one is the one I want to talk a bit more about, because this is quite extraordinary, and I totally lost control in that particular material. This is, and I won't tell you which culture, but it's a mycelium culture that I mixed in coffee waste. But the flowers you see on top have nothing to do with me. I didn't do that. It was just pure coffee mixed with mycelium. I won't give you my tricks. And actually, so you let it grow. It grows at ambient temperature. And after 3 weeks, I actually thought that sample hadn't worked. It was still covered in coffee. It was a bit mucked up. And I thought, oh, doesn't matter. And then you bake it to kill the mycelium, and then you've got the material that it's made. So I baked it, and I still thought, okay, I don't know. And then I put it under the tap to wash it, and I discovered the flowers. And if you look at them, they're fractal. Can you see that there's one that's more open and one that's sort of closed? So you can see the fractal pattern there. So this is quite, for me, that was quite spooky. I'm a textile designer. Floral patterns is what you do when you're trained as textiles. And here I am running away from flowers, working with mycelium, and then it gives me some flowers. And this is really interesting because it's really showing how the dynamic self-assembly qualities of biological system can create really interesting materials. Then what changes there as a maker is how do you control this? So this is, co-working with a living organism, but at what stage do you lose control? And I have a lot of examples where I totally lost control, but in this case, I liked that mistake. Botanical craft, I know you're hungry and it's lunch, but I'll just finish with this. This is actually not a new technique at all. This is reviving a very traditional technique that you'll find particularly in China, where you can actually mold a gourd to create, to change its shape. And what I'm interested in looking at is slow growing versus rapid manufacturing. So how can you work with nature's rhythm, nature's pattern to actually create contemporary products and growing a product as opposed to growing a material? So it takes about 6 to 8 months to grow a gourd, then you have to let it dry, and it slowly dries, the flesh inside will dry out, and then you get this sort of very wooden quality, so it's like a wooden artifact. This is work in progress. I'm working on this now to actually finish them. So it's the idea of, could we think more of growing products as opposed to grow materials? And what that means is, I think for us, we need to start to question, looking at here iconic examples of how to make a chair. So 19th century tonneau using steam to actually control the bending of wood, to mid-century looking into casting, to 21st century, will we be growing products and growing materials? Thank you very much.